record. Okay, so today is integration by substitution, and we're basically going to take the chain rule and reverse it. So up here was the chain rule. So remember the derivative of a composite function, so a derivative of two functions becomes the derivative of the outside times the derivative of the inside. Well, since we're doing antiderivatives, we're going to use something called the substitution rule. So if we're going to take the antiderivative of the chain rule, then we're going to make a substitution for the inside function. We're going to call that inside function u. So when we get our setup, the integral will become a little easier, and it'll be called f of u du. And then when you find the antiderivative, it's just going to give you f of g of x plus the constant of integration. Yes, it all sounds crazy right now, but it's not too bad. So we're going to be using substitution on integrals today. So when you use the substitution rule, you want to find the most complicated looking part of the integral and apply the substitution to that. And then what we're going to do is we're going to take that substitution, we're going to take the derivative of that substitution, and after we take the derivative of it, we're going to look for similarities in the derivative and the integral and make another substitution. Yes, again, it would only make sense when we start working this out. So let's go ahead and try number one out. Number one says the integral of 2x cubed minus 3 to the 4th times 6x squared dx. Now, the only way to take the integral of this is by substitution. So what looks more complicated? 2x cubed minus 3 or 6x squared?
The 2x cubed minus 3.
Good. So this is what u is going to be. So here, u equal, actually, I'll do it to the right side. So match these all up. So u equals 2x cubed minus 3. And now we actually have to use super proper derivative notation. So what we're going to do now is take the derivative of our substitution. And when I say super proper notation, well, when you take the derivative of u with respect to x, the left side has to become du over dx equal to the derivative of the right side, which is just 6x squared. Okay. And then what we're going to do next is take this dx and just multiply it to the right side. So what we're going to get here is du equals 6x squared dx. Okay. So this is taking care of the substitution part. Maybe I should write that on here. This is the sub. Okay. Now what's happening on the left side, let me show you. So for now, we have the integral of u to the 4th times 6x squared dx. Okay. And now we need to make one more substitution to get rid of the 6x squared dx. Well, if you look at our substitution on the right, do we have a 6x squared dx?
Yep.
We've got 6x squared dx, 6x squared dx. So guess what? This 6x squared dx, all it does is become du. So since those match up, we are left with the integral of u to the 4th du. And now we have a much easier integral to find the antiderivative of. Everything makes sense so far? It's a sub on a sub on a sub with one more sub to come in. Okay, so now we take the integral, we find the antiderivative of u to the 4th, which is going to use power rule. This is going to give you u to the 5th over 5 plus c. And now we make one last substitution because what was the original value of u? U was 2x cubed minus 3. So all we have to do is go ahead and plug that in. So we're going to get parentheses 2x cubed minus 3 to the 5th over 5 plus c. That's it. Any questions on that one?
Actually, can I get you to maybe to go over that last step again? I kind of had to step away from the computer.
Okay. So once you get the antiderivative, you have to make one more substitution. We have to plug in for u. So remember that u, we made a substitution for up here. So u was originally 2x cubed minus 3. So that's what gets plugged right in there for u. And that's it.
I'm tracking. Thank you.
Okay. Of course, we'll do it again. All right, number 2. The integral of 1 over 4x plus 7 dx. Now, what looks more complicated, the 1 or the 4x plus 7? Definitely the 4x plus 7.
Okay. I wasn't going to say
it. So here, we'll start our sub. And u equals 4x plus 7. Take the derivative, you get du over dx equal to just 4. Okay, and always we're going to multiply that dx to the right side. So you get du equals 4dx. Okay, now let's see what's happening on the left side. Right now we have the integral of 1 over u dx. So now we have to get rid of this dx. We have to make a substitution for it, which means if we look over here, we're going to have to solve this equation for dx. So that means all I'm going to do here is divide by 4. And you get du over 4 equal to dx. And now this dx and this dx match up. This means that this dx will now become du over 4. So those match up, and we're left with the integral of 1 over u times du over 4. And now I'm going to fix up the integral on the left. I'm going to pull out that fraction of 1/4. So this becomes 1/4 times the integral of 1 over u du. Now remember from your integral rules that the antiderivative of 1 over u is the natural log. So this will become 1/4 natural log absolute value of u plus c. And all we have left to do is plug in what u was. So you get 1/4 times the natural log of the absolute value of 4x plus 7 plus c. There it is. Lots and lots of substitution. Okay, any questions on that one? Let's keep rolling. Okay. 3. The integral of x squared e to the x cubed dx. Well, I'm pretty sure you know which part looks complicated already. It's definitely that e to the x cubed. So that's going to be our sub. All right. U equals e to the x cubed. Take the derivative and you'll get du over dx equal to, and here we have to use the chain rule derivative. So remember the chain rule derivative for e to anything other than just x by itself is going to be the derivative of the exponent. So the derivative of x cubed is 3x squared times the original function, e to the x cubed. Okay. And then, like always, multiply that dx to the right side. And you get du equals 3x squared e to the x cubed dx. Okay, so that's what's going on with our sub. And now back to the integral. Here's what we have. The integral of x squared times u dx. Okay, so I'm going to rewrite this as the integral of u times x squared dx. So we have to get rid of these two terms by using a substitution. Okay. So we need an x squared and a dx in there. So if you look at our substitution on the right, I have an x squared and I have a dx. So in order to get those by themselves, I'm going to have to divide this by 3e to the x cubed. 3e to the x cubed. And now my substitution is going to be du over 3e to the x cubed equal to x squared dx. All right. Perfect. I wonder if I just made this more difficult. Hang on. One moment. E to the x cubed. Hang on. 3x squared. Oh, no, yeah. Okay. So if I keep that in there, you get that whole thing. Ah, okay. So actually, this one, because if I put that ex cubed in there, this is going to make our work a nightmare. So we don't want that in there, actually. So let me reverse this. So I'm going to get rid of this and that and that and that, and that's going to stay like that. But here, here's what's going to happen. All right, we'll stop there. Okay. So this is what's crazy about substitutions, is that if we relook at this, from the original integral, I have x squared ex cubed dx. And when I took the derivative of our substitution, I have ex squared ex cubed dx. So I have the exact same statement here. So in order to make a sub for our original integral, I need to have x cubed ex cubed dx by itself. So what I'm going to do for this guy is just divide it by 3. So I'll get du over 3 equal to x squared e to the x cubed dx. And now this part of our sub matches with that in our integral, which means that all of this just becomes du over 3. Crazy. Okay, so to make this nicer, I'm going to rewrite it as 1 over 3 times the integral of 1 du. So I take the 1/3 out and I leave a 1 du in there. And now this is going to use the integral rule for constants. So this will become 1/3 u plus c. And all we have to do now is plug in what u was, and you'll get, oops, you'll get 1/3 times e to the x cubed plus c. There we go. That's much better. If I did it the other way, it would have been a real mess. Okay. So there's that. Any questions on that one? Probably not, right? Okay. Let's do another. All right. 4. The integral of 4x squared times the square root of x cubed plus 5. Well, of course, this is the most complicated part, looking part. So for our sub, I'll have u equals x cubed plus 5. Okay. And then take the derivative, du over dx equals 3x squared. And then move that dx over to the right. Du equals 3x squared dx. Okay. And now we're going to look at our original integral. And here I'll have the integral of 4x squared times the square root of u dx. Okay. So now we need to notice some similarities so we can make our substitution. I have an x squared and a dx here on my sub, and then I have an x squared and a dx here on my integral. So we need to make a substitution for x squared and dx. So let me just do a couple rewrites. First off, I'll rewrite the integral as 4 square root u times x squared dx. And then on my sub, I'm going to divide it by 3. And you'll get du over 3 equal to x squared dx. Du over 3 equal to x squared dx. Now, this part of my integral matches this part on my substitution. So we will end up with the integral of 4 square root u times du over 3. There we go. Sub on sub on sub on sub. Okay, now to clean this integral up, I'm going to take out the 4/3. So I'll have 4/3 times the integral of the square root of u du. And another cleanup, we have to rewrite the square root as u to the 1/2 du. Okay. And now we are ready to use the power rule on this. So since it's a fraction, let's do some fraction work. U to the 1/2 plus 1 over 1/2 plus 1. Power rule on that. And here we will get 4/3 times u to the, that's 2 over 2, u to the 3/2 over 3/2. And then remember to flip this fraction. And we'll get 4/3 times 2u to the 3/2 over 3. Almost done. I'll multiply straight across and I'll get 8 over 9 u to the 3/2. And then of course, plus c. But we're almost done because we now have to replace u that we made in the very beginning. Okay. So our final answer is going to be 8/9 times x cubed plus 5 to the 3/2 plus c. There we go. All right, good stuff. Next one. 5. The integral of x over x squared plus 1 squared. Okay. So here, of course, the most complicated part looks like the x squared plus 1. So for my sub, I'm going to have u equals x squared plus 1. Then du over dx equals 2x. Multiply that dx to the right side, and you get du equals 2x dx. Okay, so that's what's going on my sub right now. Let's look at our actual integral. After the substitution, you now have x over u squared dx. So we have to get rid of x and dx. Well, if we look at my substitution, I have an x and a dx. So to get dx by itself on the right side, on my substitution side, I'm just going to divide it by 2. So you'll get du over 2 equals 2x dx. Okay. And then I can even rewrite this integral before I make any more substitutions. I'm going to rewrite it as x dx over u squared. And now there's our x dx. Here's our x dx. So that x dx becomes du over 2. So you're going to get the integral of 1 over u squared times du over 2. Okay. The integral is all in terms of u, and we just have to clean it up now. I'll pull out that 1/2. You'll get 1/2 times the integral of 1 over u squared du. Rewrite the integral one more time. 1/2 times the integral of u to the -2 du. And then we get to use our favorite power rule on this. And this will become 1/2 times u to the -1 over -1. Multiply straight across. I'll get u to the -1 over -2 plus c. And don't forget to plug that value of u back in. So here you're going to get equal to parentheses x squared plus 1 raised to the -1 over -2 plus c. And that is a fine answer, but I hate negatives in my denominator. So I'm going to rewrite this as -1 over 2 times x squared plus 1 plus c. There we go. Okay. Any questions on that page? Can even go back over number 3 if we need to. Guys hanging in there?
Yeah, think so.
All right. Okay. All right, next page. So sometimes U substitution doesn't always work without having to do another substitution within substitution. So we're getting real inception-like here, okay? So this means that if you can't express the integral all in terms of U, like we've been doing, then we're gonna have to create another substitution. Okay, so don't get lost in all the substitutions. Okay, so I'll show you how to work this. Number 6, the integral of 5x minus 7 times x minus 1 to the 4th. Okay, so for this one, we are going to let u equal, and of course, 5x minus 7 looks complicated, but it's not as complicated as x minus 1 to the 4th power. So we are going to let u be my x minus 1. Okay, so here we go for the sub. So u equals x minus 1. Du over dx is just going to be equal to 1. Multiply the dx to the right side, and du equals dx. Okay, so let me rewrite what we have so far. We have the integral of 5x minus 7 times u to the 4th dx. Okay, so the only thing I can see that we can get rid of is this dx and that dx. Those are the only things that match up here. So if I rewrote it again, you'd have 5x minus 7 times u to the 4th du. But we want this integral all in terms of u. So we have to do something about this guy, 5x minus 7. And the only way to get rid of that x is to make a substitution based off the substitution we made already. And what we're going to do is solve u equals x minus 1. We're going to solve it for x. So here's another sub. So I'll rewrite it. U equals x minus 1. Add the 1 over, and you get u plus 1 equals x. So now x is equal to u plus 1. So what you're going to do with that is plug it in for this x. And when we do that, this will put the integral, all in terms of u. So let me show you. We now have the integral of 5 times u plus 1 minus 7 times u to the 4th du. Okay. And now we have some cleanup to do. You're going to distribute this 5, and we get the integral of 5u plus 5 minus 7 times u to the 4th du. Still some more cleanup. We get the integral of 5u minus 2 times u to the 4th du. Okay, almost there. All right, and u to the 4th, I'm going to just rewrite it as regular old u to the 4th du. Because now what we're going to do is take u to the 4th and distribute it here and here. So this means we now have the integral of 5u to the 5th minus 2u to the 4th du. Which means we are now ready to find the antiderivative. Our integral is all in terms of u. So this means that we are going to use power rule on both of these. So I'll start over here, which means that we're going to get 5 times, and if we use power rule on u to the 5th, that's going to be u to the 6th over 6 minus 2 times power rule on u to the 4th is u to the 5th over 5. Put it together, you get 5/6 u to the 6th minus 2/5 u to the 5th. And we have to just plug in what u was and add that c on. So we're going to have 5/6 times x minus 1 raised to the 6th minus 2/5 times x minus 1 to the 5th plus c. Wow. So we did a sub within a sub in order to make the integral all in terms of u. Okay. Any questions on that one? All right. Let's do another one. Okay. 7. Integral of x over the square root of x plus 2. Well, of course, here that x plus 2 is more complicated looking than the x. So for our sub, we'll have du equals x plus 2. And I'm just going to rewrite this as du equals 1 dx. So I just skipped a step there. Normally it'd be du over dx equals 1, but I'm multiplying that dx to the right side already. So that finishes that. Okay, which means let's go over here, look at what we have. You have the integral of x over the square root of u dx. Well, once again, this dx matches that dx. That's 1 dx. So we'll make a substitution for that, and you'll get the integral of x over the square root of u du, which means that we need to get rid of this x. So we make another sub within a sub. So oh, sorry, maybe I'm skipping too many. That should have just been u. There we go. Okay. And here's our sub. I rewrite this. U equals x plus 2. Subtract that 2 over. U minus 2 equals x. So that's what's going in for that x. So we are going to have the integral of u minus 2 over the square root of u du. So that gets plugged in for x. Okay. And now our integral is all in terms of u. So still more fixing to do. So I'm going to rewrite this first as the integral of u minus 2 over u to the 1/2 du. And then I'm going to split this into two fractions. So you'll get the integral of u over u to the 1/2 minus 2 over u to the 1/2 du. Okay. So we split it into two fractions, and then we simplify some more. I'll get the integral of u to the 1/2 minus 2 times u to the negative 1/2 du. So what we did was on u over u to the 1/2, remember you subtract your exponents. So that would be 1 minus 1/2, which would give you u to the 1/2. And then on the second one, I just flipped the u to the numerator, making it u to the negative 1/2. Okay. And now we are ready to find the antiderivative by power rule. And since this is a fraction, definitely put the work in. Let's see. First one, you'd get u to the 1/2 plus 1 over 1/2 plus 1 minus 2 times u to the negative 1/2 plus 1 over negative 1/2 plus 1. And then clean it up. This would be u to the 3/2 over 3/2 minus 2 times u to the 1/2 over 1/2. And now flip both of these fractions. And we're almost there. This would give you 2u to the 3/2 over 3 minus 2, this one's almost done, times 2u to the 1/2. All right. Keep this going here. All right. And then rewrite this as 2/3 u to the 3/2 minus 4 u to the 1/2 plus c. Okay. Very last step is plug in what u was. U was x plus 2. There we go. There it is. Read and weep. Don't weep too much though. Why do we show this to business majors? I have no idea. But
don't tell me don't tell me that.
no, but it'll come in handy on the next couple of sections, I think. Other than that, it could be we just squeeze it into the curriculum. And it's just a fun time.
True that.
All right. Last one. Do it again. Okay. So here we go. Of course, there's the more complicated looking part. Sub, we get u equals x plus 1. Take the derivative and we get du equals 1 dx. There we go. Okay. Which means what's going on over here? You have x times the square root of u times dx. These dx's match up. So our integral is now the integral of x times the square root of u du. And now we have to make a sub for this x. Okay. Which is going to happen over here. Okay. So this part, we make a sub, u equals x plus 1, move that 1 over, and u minus 1 equals x. Okay. And then we get the integral of u minus 1 times, and the square root of u, I'm going to rewrite as u to the 1/2 du. Okay. And then we're going to distribute u to the 1/2. So we get the integral, and u times u to the 1/2, when you have the same base, you add your exponents. So that's going to be 1 plus 1/2, which will give us u to the 3/2 minus u to the 1/2 du. Okay. And now this is all set up. We are ready for power rule on both. So this means we're going to get u to the 3/2 plus 1 over 3/2 plus 1 minus u to the 1/2 plus 1 over 1/2 plus 1. Clean up, clean up, clean up. And this is going to be u to the 5/2 over 5/2 minus u to the 3/2 over 3/2. And then once again, flip, flip. Let's see, come over here. Yeah. And you're going to get 2u to the 5/2 over 5 minus 2u to the 3/2 over 3 plus c. But now plug in u and you get 2/5 times x plus 1 to the 5/2 minus 2/3 times x plus 1 to the 3/2 plus c. And that is done. So that last page gets a little crazy. All right, but we are done. Those are integrals by substitution. So if you got questions, stick around.